guys, how you doing? Welcome back to another episode. So today we'll be solving this very interesting problem called contains duplicate 3 and its lead code 220. This was asked at Facebook, Microsoft, Google, Apple, Palantir, Airbnb and LinkedIn, and I think many other companies as well, as this is very interesting and very good problem to solve. So given an array, so we'll jump into the problem statement first. So the problem statement goes like this: given an array, find out whether there are two distinct indices I and j in the array such that the absolute difference between nums of I and nums of j is at most t, right? And the absolute difference between I and j is at most k. So it's telling that find at least one pair. So find at least one pair, and if you get one pair, just return true. So find one pair so that those pair are I and j, those pairs are at a distance of at most k, right? So it has to be less than or equals to k. So if I write it down the conditions, it has to be I minus j, like absolute value of I minus j has to be less than equals to k, and another condition is absolute value of array or nums of I minus nums of j has to be less than or equals to t. So you have to find at least one pair that satisfies both of this condition. That's it. That's all the problem wants you to say. Um, that's it, right? Now, what is the so before discussing the solution, if you want to solve this problem, I would highly suggest you to pause the video right now and jump into LeetCode 220 and try solving this problem. Okay, so let us first understand one test case, one sample case actually. So in this problem you can see like 1 and 1, they have a difference of 0. That is what t is, because t is 0, and 1 and 1 have a difference of 0, whereas the indices between them has a difference of 3, 0 and 3, right? So basically if we take this window and we can find out like what is the, if there any pair is if there is any pair which like satisfies both the condition, then we're good to go. If we take this example, you can't find any pair which has a difference of 3 or less than 3. All of them have a difference of 4 or 8 or more than that, usually in this case 4 or 8, but nothing else. But it's not less than or equals to 3, so that's why it's false. So if you can understand, like, this can be solved definitely using two for loops, and can be using a naive brute force implementation of n square. Like, we iterate for all the pairs and check like which pair satisfies both of the conditions. But definitely we want to optimize on that, optimize on the time taken, and maybe we need some extra data structure to store this. So if you have a look at this problem from a different angle, it's like, if we could, like, let's take this example 1 0 and 1 1. So we need to find that, like, at least the difference has to be 1, and the distance can be less than or equals to 2, and the difference has to be less than or equals to 1, right? So we can get a condition. So we can just like check this element, first two element, and then check this two element, and then check this two element. Because why I'm doing that, because my t is, because my k is 1, right? And two elements have I minus j equals 1, which are like consecutive. In this case k is 3, so I'll have a window like this and I'll compare these elements inside that, because I don't need to compare elements ahead of this part, right? Because they already do not satisfy this first condition we have here, because I need to find elements which are at most, which at least satisfy this condition. So for satisfying this condition, I can check within a window, and then within that window I can check for this condition, right, for the current index, right? So that way we can use, like a sliding window kind of approach, and this can be solved in a better way. So let us have a look at the solution, and let us try coding the solution with the approach we thought. So we will use Java. We'll use Java for now, and So we'll use a tree set because Java has this sorted set which will help us directly in this solving this problem. And even you can do this in C++. C++ has stores set. The STL containers in C++ can store sets in sorted order. So for now we'll be using the tree set implementation. And okay, so we'll use what will there is no constraint given for the elements, so we'll use it's an int, but okay, let's go with an int. Okay, we cannot go with an int because it's integer, right? So integer, let's say ts. I am not naming the variable properly, but I would highly suggest you to name variables properly because in an interview it's very much important. Okay, so yeah, so okay, next what we need to do is just create an iterator and a variable, loop variable, and I'll just iterate for like while I is less than nums of length, that's it. And my current element would be nums of I. Now you have to understand what we do from here. We basically check for the current element uh, if there is an element less than the current element, and if there is an element greater than the current element, just less and just greater. So if all the elements in this set, we could somehow open the set and sort that set and find out what is the just the previous element, just the floor element you can call it, and we can compare it with that. Similarly, if we could compare it with just the greater element, the ceiling element, and if we could compare it with that, and if we could check that if we satisfy the condition, then we are good to go. So tree set provides these two methods, and you have floor and ceiling method to do that. So we'll calculate the floor value. Okay, so this integer floor will take tree set dot floor value of current, and integer ceiling would take the ceiling value of current. So basically we want to get the number here, we want to get the number which is just less than, like just less than that current element, and ceiling is the number that is just greater than. So that's how we do it. And here we just need to check the condition. So if floor is not null, because it can be null, right? If you're checking for the floor element, for the smallest element, it will be null. There is no element which is just smaller than the smallest element in the set. In that case it would be null. So if it is not null, and you need to just check if nums of basically current element minus floor, because floor is less than the current element. If it is less than equals to t, so it satisfies the condition, right? And okay, it should be or, because we are checking for either of these conditions. And if the ceiling value is not equals to null, and if current minus ceiling is less than equals to the maximum we are looking for, at most that thing, in that case we just return true. We just don't need to check anything else. That's it. We found a pair. What is the pair? The current element and either of this, either this one, the floor value, or the ceiling value. So we found a pair which satisfies this condition. We don't need to check all of them. Whenever the adjacent elements satisfy it, we are good to go. And by adjacent I don't mean adjacent in terms of uh, exact place in the array, because let's say when we take this one, the adjacent elements would be like exactly not the same, but when we use floor and ceiling, it sorts it internally. It checks for the greater than and less than value exactly in the set, right? So that's what we're gonna use. And that's it. I think we can increment the value of I, and like, okay, right, if we do not find the value, so we need to add the value in the set. the current value should be added in the set, because that's how, like, the set needs to slide to the right side, and to slide it to the right side we need to add the current value. And how about removing the element from the left side, because it has to slide, right? We cannot keep on adding, we need to also remove it from the left side. That's how we'll maintain, that's how we'll basically optimize the time, because we don't need to search the entire array, we need to search only k elements. So if my I is greater than k, so y is greater than k, because when I have at least k elements, that's when my sliding window is full. When I have more than k elements, I don't need to check that, because if it's greater than k, my this condition does not satisfy. I want to satisfy this condition, that's why I'll keep only k elements in the set. So I can just remove the element at, like, I minus k minus 1, obviously, and then return false, right? Okay, the return false would not happen here, it would happen outside the while loop. Return false, right? So let us try with that. Okay, we get a wrong answer. Let us understand why is that happening. uh okay, it has to be c minus current, because c is greater than current, right? Yeah, I think this would be enough. Slide right, remove from left. I'm writing remove from left, but it's actually not removing from left. It's actually removing the first element that was inserted, like oldest element inside the set, right? So I think that is it. We are good to go. Let us try submitting this, and if we face anything, we'll just resolve it. Okay. We're getting a wrong answer. Let's understand why. Okay, so as you can see, we have a long integer, so it's like we have to use long number here. So it's better we convert it to long. And I think here we have to make it long. That's it, I guess. Is it? So yeah, here it has to be long. So we're just converting it to long so that we don't face this issue, right? I hope this time it would work. It's incompatible. Okay, my bad. It has to be long, right? That's good to go, I guess. Yeah. So let's try submitting this. Cool. We are getting success, but I think we can even optimize this. Like, this is currently taking what, um, big of n log n, because these methods take log n log big of n log k, pardon me, because these methods take k log k time, and the entire iteration of n number of times, so it's n log k. There are better methods to optimize it, maybe to make it linear time, but generally in interviews you try to talk about, like, interviewers won't exactly ask you to optimize it if it's very difficult, but if it's possible, we'll definitely discuss it in the next video. We'll probably go for another video where we'll optimize this to n linear time. If you want to know that how we'll do that, please put some comments in the comment section, and I'll definitely cover that, how to solve this in linear time. But this is the big of n log k, and I think we can help ourselves in covering another test case, because if the length of the array is less than 2, we really don't need to check for all of them, right? Because let's just understand this. Like, if the length of the array is 0, right, or if it's less than 2, basically if it's 1, then it will always be true. That is, it's always true, it's 0, right? Because it's always false, because we do not have a right answer. In that case, we do not have a pair, because there is only one element, we do not have a pair. And if k is equals to 0, so if k is equals to 0, you can never find a pair. I and j will always have to be in the same spot, right? So in that case, you don't find a pair and you need to return false. So this just handling one extra condition separately, I think that's good enough. That's it. So I think we reduced our time, or probably increase it. This doesn't matter, but I think you guys understood the solution, and hope this was useful to all of you. So do like the video if this was helpful, and write down in the comment section what kind of videos or problems you want me to cover. And that's it. All the best for your interviews. Good luck.